Okay, hi everybody. You're gonna have to bear with me. This is my first time recording a physics video on this new software. So the cool thing about this, anything that I do, if you get stuck on any part, you can pause it at any time, no problem. Pause it, rewind it, and we'll see how this goes. So as you can see here, what I've got is I have your sample data. I've got sample data from the lab. And what I'm going to do is I'm just going to walk through how to do calculations for all of the columns in your calculations table. So what I'm going to do is I'm actually going to just do case 1, trial 1. Okay? I'm not going to do all of these, but I'm going to do one for each of these. And then this is what you can use as your guide when you're finishing your calculations in case you get stuck. Okay. So let's go ahead up here. First of all, I'm going to start with initial potential energy. So we all know P, initial potential energy, I abbreviate as PEI. And remember, initial potential energy is equal to the mass times the gravity times height initial. The biggest thing that I'm seeing is we're not using proper units. So I have actually already converted my grams to kilograms. But in case you missed that, I want to give you an example of what that looks like. So this first one, I've got 521 grams for my mass. And I need to get this in kilograms. So I'm going to set up my dimensional analysis. This is what that's called, dimensional analysis. I'm measuring dimensions and I'm canceling them out. I know my conversion is 1,000 grams equals 1 kilogram. Okay? So I'm going to put grams here on the bottom so I can cancel grams. So if I put 1,000 grams here, that way I have grams on top, grams on the bottom, cancel, no problem. 1 kilogram. I can use a different color, show you that grams cancels the grams. Note that I do not cancel out the number. The number's still there. 521 divided by 1,000, I can do it quick by moving the decimal, or I can plug that into my calculator over here. Okay, 521 divided by 1,000, and just like that, enter, gives me 0.521. So now I know that I have 0.521 kilograms, which is actually what I have right here. Okay, so I'm not going to show that conversion from here on out. I've already converted. Last thing you need to do is you need to convert from centimeters to meters. I've already done it here. Let me show you how to do it. I did measure for my initial height. I did have 8.4 centimeters. And in order to convert centimeters to meters, I got to get a conversion factor. That's 100 centimeters equals 1 meter. Okay. So, draw my dimensional analysis little block again. In the end, I want meters. Plug in, I'm going to put centimeters on the bottom. Why? Because I want to cancel it. So I want to cancel centimeters, one on top, one on bottom, gets rid of it. 1 meter is going to go on top, different color, go purple. Boom, boom, 8.4 divided by 100. I can move the decimal, or I can come over here, and I can do 8.4 divided by 100, enter, gives me 0.084. And I had to kind of rewrite over that. And that's H initial. So now you can see how to convert meters to centimeters and kilograms to grams. So that's what you're going to be doing. I'm going to erase this now so I have some more room to work with. Make sure you're getting it down. And again, pause at any time, guys. I've done this a lot. I realize this isn't as obvious when you're first learning this. And that's why I want you to be able to work at your own pace. That's the benefit of doing screencasts, doing these podcasts. Okay, so let's go do it. PEI, well, mass for case 1, trial 1 is 0.521 kilograms. Make sure to include your units. That way when I go back and you're like, Mr. Sellers, I got the wrong answer. What did I do? All my numbers look right. Yeah, but you didn't convert. And you're going to catch that faster yourself if you list the units. We all know gravity is 9.8 meters per second squared. Ooh. Okay, height initial, 0.084 meters. Let's go back to our calculator. Okay, let's plug it in. we've got 0.5, there we go, 0.521 times 9.8 times 0.084, enter, and there I go, 0.428, or if I round that, 0.429, right, because I'm going to round this 8 up. So it's going to be 0.429. Actually, I'm going to round it all the way to 0.43. I'll come over here, and this is in joules, so I get 0.43 joules. That's PEI. So what I can do is I can come down here to initial potential energy, and I got 0.43. Okay, now I got to do final. I'm going to do this quick, next one. The only thing that's changing is I'm doing PEF, which means I'm going to use the same mass, the same gravity doesn't change, and final height this time. The final height this time. So here we go. 0.521 kilograms, 9.8 meters per second squared, and my final height was 0.044 meters. 0.044 meters. Note that these are already converted. Already converted, guys. I can come over, and I've actually already done this. And, well, actually, I'll show you how it looks. Where's my calculator? Okay. On 0.521 times 9.8 times 0.044. Enter. And I get 0.224. I'm going to round this up to this point right here. So it's going to be 0.22 because 4 is less than 5. So I stop at 0.2. Come over here. So this is going to be 0. That looks like a 6. That looks like a 6. We use purple. I like purple. My mom's favorite color. And I switched to black. Oh well. 0.22 joules. Okay, that's potential energy final. I scroll on down here, and I get potential energy final. Notice I'm still in case 1, trial 1. I haven't changed anything. Well, the next column is change in potential energy. We all know change, or delta, that's what change, this is delta, equals PEF minus PEI. So let's plug that in. PEF is 0.22 minus PEI was 0.43, which gives me, quick mental math, gives me negative 0.21 joules. Now this is negative, and the reason why it's negative is because this energy is being lost. Remember, if I've got a ramp and I've got the car up here and there's potential energy in the beginning, once that car gets down here and it's moving, right? Now it has kinetic energy. So this potential energy is being transferred. So we're literally seeing a loss of energy, and that energy, if it's all conserved, should be kinetic. It should be moving energy, right? So that's what we're testing in this lab. We're seeing, was it all conserved? Or was some of it lost? Okay, so next thing we need to calculate. Oh, we just did. Change in potential energy was negative 0.21. So I am going to not write the negative. I'm not going to write the negative because I just want to know the magnitude. I'm not really concerned about, I just want to know how much energy was lost. And we're going to compare the change to the change over here and then calculate the percent difference. Kinetic energy. Okay, initial. Well, kinetic energy equals 1/2 mv squared. And if you recall, what's the velocity when the cart is at the top of the ramp? Well, you were holding it. Kinetic energy means movement energy, right? So if there's no movement, there can be no kinetic energy. So guess what? I just made your life so much easier. All KEIs are equal to 0 because it's not moving. Not moving up here. Not moving at the top of the ramp. So let's go do this. It's going to feel good. You can actually do this for all of them, right? Initial kinetic energy, boom, boom, boom. Actually, that's not even It's not even 1. Oh well, you get the drift. So what we really are concerned about is the final kinetic energy. How much potential energy was changed into kinetic energy? Okay, we're going to use the same equation. We're just going to add a little F for KE final. And we're going to add a little F to the velocity final. Okay? Now somebody asked, why don't I put an F here? Why don't I put an F behind mass? Well, does mass change from initial to final? It doesn't. It doesn't. So I'm going to have, here we go, KEF equals 1/2. What was my mass again? Oh yeah, my mass. I can come up here. Remember, I'm just doing one case. I'm doing the top one. 0.521 kilograms. I like it in kilograms. It's the units I want. So this is going to be 0.521 kilograms. And then I've got velocity. And my final velocity is squared. Now if you note, look, I've got 3 velocities here. But that's why I did an average. So I'm only going to use my average velocities when I'm doing this calculation. Pretend that average velocity is my final velocity. Okay? If I'm moving too fast, guys, I know I'm scrolling up and down. Pause me at any time. Okay, final velocity. It was 0.88. And luckily for us, it was already measured in the right units, which was meters per second. That's what the GLX spit at us. And this is squared. The squared is outside. I am squaring the units and the number. I'm squaring everything. So I'll show you what this looks like in the calculator. Okay, on 1 divided by 2. And let me go ahead and put this, clear this. Do it in parentheses. 1 divided by 2 times my mass, 0.521, times my velocity squared, 0.88, parenthesis, in the parenthesis, and squared. That little caret means squared. Plug it in, and I get 0.201. I'm going to round to this, so it's going to be 0.20. Over here, and energy and work have the same unit, 0.20 joules. Okay, so I can go back up here and I can box everything I've gotten so far. So we just did the final kinetic energy. Let's come on down. Final kinetic energy was 0.20 joules. I didn't write the joules in that one. Let's find the change in kinetic energy. Well, change. We already did this. KEF minus KEI. This was 0.20 joules minus 0 joules. Wasn't moving in the beginning. So we get 0.20 joules. Same thing. And so our change in kinetic energy. Pretty good. Let's look. What we got? We've got change in potential energy, change in kinetic energy, and according to the law of conservation of energy, energy is conserved, it is saved. So whatever potential energy I lost should equal whatever kinetic energy I gained, right? Kinetic energy and potential energy, no matter what, KE plus PE is equal to E total, which is always constant, always conserved. But we can clearly see that I lost a little bit of energy. What happened? Well, the track heated up. There was noise. There was friction. All these things decrease energy, but that's pretty good. So now we're going to use our percent difference equation. In order to do that, I'm going to need some more room. I'm going to come down here and get some more room. And we're going to do this last one, which is percent difference. Let's check this out. Okay, so percent difference. Now you already have this equation. It's on the back of your sheet. So I'm going to look at this as we go. It's going to be absolute value, PE minus KE, absolute value, divided by absolute value, PE plus KE, times, and it's a percent, so this is times 100. Okay, so let's go ahead and do it. Now, all these are change-ins. I know they didn't write this on your lab handout, or I didn't. I didn't write this, but you know where I got the lab from. They didn't write it. This has changed. They want you to be using this column, okay? When you're doing percent, use the change-ins. These ones right here. Okay, we're just about finished, guys. Let's go ahead and get down and dirty. Now remember, we're just doing case 1, trial 1. Okay, percent equals change in potential energy, 0.21. Minus change in kinetic energy, 0.20. Divided by change in potential energy plus change in kinetic, there we go, times 100. A little complicated, so what we're going to do is we're going to do this in steps when we solve it on our calculator. So let's go ahead and I'm going to draw a line just so you see. That's not a divided by sign, okay? I'm just moving on. This is going to be 0.01, right? 0.21 plus 0.20, 0.41, absolute value, these are ones. Okay, times 100. And I'll do the division first. Okay, here we go, 0.0, right? They're already positive numbers. And I get a stellar percent difference of 2.4%. I'm going to round to this, so this is less than 5, so it's going to be 2.4. That is impressive. That is barely any percent difference. So barely any energy was lost. In fact, if you are less than 5%, it's pretty good. We're pretty happy about that. So I'll come on up, and for my percent difference, I get 2. So now I have calculated all of these for case 1, trial 1. What you need to do in your lab report is you need to calculate all one of these on your own. And then if you've got 3 group members, let's say you got 2 members, I would have somebody do maybe the first 2 trials, next case 2 and case 3. Okay? Change it up a little bit so each person gets 2. You need to show me full calculations for at least one of them. Is that clear? All right. Good luck. If you have any questions on this, ask me in class. Remember, rewind, go back, solve it out. What did you do wrong? Your numbers should be fairly close to this. Not exactly, but somewhere in that realm. All right? Good luck.